Hey, Year 11s, we're now going to do some examples from your exercise. We've got exercise 13E, which is to do with logarithms. We're just going to look at all the rules here and see what we can play around with. So let's pick, let's do A, because there's a fraction there, and let's look at another one. Let's do D. Okay, so I'm going to do 4A. 4A, you have half times log base 10 of 16. Plus 2 times log base 10 of 5. In order to do this problem, we can't combine these two together and ignore the half and the 2. A lot of students do that. So a lot of students will use law number 1 and then just write log base 10 of 16 times 5, right? You can't do that when there is a number at the front. So the only thing you can do at the moment is you have to use rule number 3 first. Rule number 3 says that you can bring the power up as part of the logarithm. So this now becomes log base 10 of 16 to the power of half, which really just means square root of 16, plus log base 10 of 5 squared. Now there you can actually now combine them together because there are no numbers at the front. So no coefficients of log, okay? So here we can then say, if I just simplify it, to make it a bit easier, so log base 10 of root of 16 is 4, and remember it can't be negative because the inside of a log can never be a negative value. That's why usually you write plus or minus 4, but we know that it can't be negative. And then log base of 10, 5 squared is 25. Okay, using rule number 1 we can combine the two together, so it's log base 10 of 4 times 25, which conveniently simplifies this down to log base 10 of 100. And we know that if we understand what logarithms mean, this is saying 10 to the power of what is equal to 100. And hopefully you know that 10 to the power of 2. So that's why log base 10 of 100 is equal to 2. Okay, I'm probably just going to make this a bit smaller just so I have a bit more space. So let's just make that a bit smaller. There you go. So we've done A. Let's have a look at D. D. Let's do D. Here we go. D. Log base 4 of 32 minus log base 9 of 27. So there's a problem here. We can't combine these two expressions because they have different bases. But if you try to understand, and let's work them individually, log base 4 of 32, what does that mean? Log base 4 of 32 actually is the same thing saying 4 to the power of what will equal to 32. Well, now we can solve using exponentials. This is the same thing as saying 2 to the power of 2x is equal to 2 to the power of, I think, 5. Okay, and then you can see here solving for it, therefore 2x must equal to 5 and x equals to 5 on 2. So right there, that tells me that log base 4 of 32 has to equal to 5 on 2. Because remember, when you're working out for log, you're actually working out for the power. That's what you're asking. So log base 4 of 32 is equal to whatever that power is, and x is equal to 5 on 2. So that's why I know that is the answer for log base 4 of 32. Now, if we do the same for log base 9, unfortunately, oh no, my pen's back. It wasn't working just then. Log base 9 of 27, this is the same thing again. 9 to the power of what is equal to 27, and you follow the same idea. This becomes 3 to the power of 2x equals 3 cubed, and therefore 2x is equal to 3 and x equals to 3 on 2. So that means that log 9 of 27 is actually equivalent to 3 over 2. So putting them both together, you've got log base 4 of 32 is equal to 5 on 2, and you're minusing log 9 of 27, which is 3 on 2, and that is the same thing as writing 2 on 2, which is 1. Okay, I'm just going to rub that on out, and there you go. So I'm going to make this a bit smaller. So that one was a tricky one, so some of you might have found that tricky to do, but that's the trick. That's how you would do those two. Have a go with the other ones. Let me know if there's any other ones you'd like me to have a go with, but this is a really good exercise to train your logarithmic equations and skills.